Welcome back and greetings of the day. We have an interesting problem here and we're going to play around with stacks and queues. Let's get started. So this is the definition of the problem. Implements queue using stacks. We know that queue is a first in, first out principle, and here we're going to implement it using two stacks. The expected operation is pushes an element into the back of the queue. Pop removes an element from front of the queue. Basic queue operations, which is basically NQ and DQ operation, which we have discussed. Peek returns the front of the queue and then empty checks if queues are empty. Basically, it checks if both stacks are empty, then queue is empty. This is a use case, and let's get started. May it be a railway ticketing system or a boarding pass lane, we know that the person to enter first into the queue is the one who's going to be served first. So it's based on first in, first out principle. Here, to implement queue using stack, we make use of two stacks. One is called in stack, another is called out stack. And the use case is as given here. We are required to push three elements and then pop one element out of the queue and then again push. We call push here because we are using stack, otherwise it's essentially referred to as NQ operation in queues and DQ operation for pop. That's when you're entering into the queue, it's called NQ, and when you're being served or exiting the queue, it's called DQ. So we are first enqueuing three elements, 1, 2, and 3 initially, and then dequeuing an element, and then again enqueuing another element, 5, into the queue using stack. So we are kind of mimicking queue implementation with stack. To do that, we need two stack. We basically make use of two stacks. So if we were to push 1, we check if out stack is empty, and if out stack is empty, we simply push 1 into in stack. Next, we have a requirement to push 2 or NQ2. Again, we check if out stack is empty. If it is empty, we simply take and push 2 here. Likewise, the third element, we again NQ 3. Now comes the pop operation. When we are performing pop operation or DQ operation, we see that the in stack is empty, and until in stack is empty, we take every element from in stack and push it into out stack. This goes into a loop, and then we pop out or DQ 1. So by definition of queue, we know that the first element that entered into the queue, which is 1, is now being served when you perform a pop or a DQ operation. Now comes the push operation or again NQ operation. Until out stack is empty, we take every element and push it into in stack. And then now to push our NQ element 5, we push it like this. That's it. With this, we have been able to achieve our mimic implementation of queue with stacks. As we just discussed in our whiteboard session, we are going to use two stacks to implement a queue. So we will go ahead and initialize those stack here. And before we initialize, we declare them, define stacks, private. We are going to use stack class of type integer. We call it as instack. And then we're going to have another stack which is going to be outstack. We'll initialize the stack in the constructor. So instack equal to new of stack angle brackets and thus open close brackets. Likewise, we are going to also have outstack initialization. Done. Now we have the queue operations using stacks. This is actually enqueue operation. I would have appreciated LeetCode to call this as enqueue instead of push, but I understand they've called it as push because we are using stack. Purpose DQ. Implement enqueue. Okay. As I said earlier, we are going to check if outstack is empty, and until outstack is empty, we're going to pop out elements from outstack and push it into instack. And if outstack was empty, we simply go ahead and push this element into instack. So we'll assume that instack is eligible for being pushed where outstack is empty. That's case 1. And case 2 will be where outstack is not empty and required to pull out the elements to be pushed into instack. Dot is empty instack dot push. What do we push? We push every element from outstack that is popped out. We are done with the implementation of push operation that's called out here, which is basically the enqueue operation. We are now going to implement the pop operation using stacks, which is basically the dequeue operation in the queue. We are going to do exactly opposite of what we did with push. Basically, we are going to check if instack is empty, and until instack is empty, we are going to pop out the element and push it into outstack. So I'm simply going to copy paste this here and rename it. Check if instack is empty, and until instack is empty, going to pop out instack and push it into outstack. If instack was already empty initially, then we simply return outstack dot pop. Before we go ahead and implement the leftover functions peek and empty with the implementation of cube here, we'll ensure that outstack is not empty when we are attempting a pop. Otherwise, it's going to throw an exception. Let's say we are first time attempting to pull out an element from outstack when both the stacks are empty. None of them have gone into instack and none of them have gone into outstack. So that's the case when both stacks are empty and we attempt to pull, we're going to have an exception. So if outstack is empty, we are going to return -1. Otherwise, we'll pop the element from outstack and return that. Alright. Next we implement empty. Note that this empty is different from the one that comes with the stack class. So this empty expects us to check if both stacks are empty. So check if stacks in stack and out stack are empty. So we will return in stack dot is empty and out stack is also empty. The condition that matches. So this is the state when we had created in stack and out stack and when all the elements from the in stack and out stack are retrieved. Okay. Now peek is as simple as going and peeking into a stack. Now peek expects us to return the element that is in front of the queue. Return the element in front of the queue. So if we were to return the element in the front, we need to transfer all of that in the in stack into out stack and then pull out the one that is there on the front. So if out stack is empty, until in stack is emptied out, take out every element from in stack and push it into out stack. While in stack gets empty, out stack dot push every element that's coming out of in stack. Okay. If out stack is empty, return -1. Otherwise, look into the front of the stack. That's basically perform peek. Okay, we are done with the basic implementation of stack using, sorry, queue using stack. So as usual, before we run on the console here and verify the test cases, we'll see if the code is full with clear syntax and semantics. Essentially make it error free. I see there's a need for semicolon missing here. It's coming from start. There's semicolon missing here. This needs to be in stack dot push, and what are we trying to push here? X. Okay. Alright, now we are ready to verify our test cases and run. So from the console, we are required to initialize the queue, push it twice, and then peek, pop, and then also check if the stacks, both in stacks and out stack, are empty. Okay, luckily we have our result successful. Good. We are done with our implementation of queue using stack. Thanks for watching. You've been so far hearing from Vidya. If you like the kind of videos that I'm making, consider subscribing.